am Dr. Lalchand and you are watching Electronics Byte channel. In this PSPICE tutorial, I welcome in the lecture 4, Transistor as an Amplifier. So in this lecture we will simulate the circuit of amplifier using transistor. So in short, we should understand what is amplifier. So amplifier is an electronic circuit which amplifies the weak signal applied to its input and we get large signal at output. The amplifier is built up of transistor. So let's see how a transistor works as an amplifier. So this is the circuit of common emitter transistor amplifier. So before we apply any weak signal, we need to give an appropriate potential at every terminal of transistor. Here we have used potential divider arrangement for base biasing. So here we are using R1 and R2 to give the proper biasing voltage to the base terminal. The resistor RC is used to give proper biasing voltage to the collector and RE is used to ground the emitter terminal of the transistor. C1 and C2, these are the coupling capacitors, that is for the DC blocking purpose, and CE is a bypass capacitor. In short, we can observe that at collector terminal there is more positive potential is applied than base terminal and emitter is grounded through RE resistor, so that the transistor should work in active region. Now we will apply weak signal to the base terminal via C1 capacitor. So consider that the weak signal is sinusoidal wave. So let us consider during the positive half cycle of the input signal, VB voltage will slightly increase and hence IB current will increase, which means the number of electrons from emitter will travel toward base terminal, but after reaching at base terminal, these electrons will feel more positive potential toward collector as compared to base, and very few amount of electron will be diffused in the base region and rest of the electron will rush toward the collector region. So these electron will increase the amount of collector current IC, which leads to increase in the voltage drop VC across RC, which leads to the decrease in VCE with respect to VCE. So this can be understood by this equation where VCC equal to VC plus VCE. Now VCE equal to what? VCC minus VC. So what is VC? VC is the voltage drop across this RC resistor. VC is the potential difference between collector and emitter, and here the bypass capacitor is applied. So for AC circuit, voltage drop across this RE will be 0. So we are not including this V here. So VC will be what? VCC minus VC. VC is nothing but IC into RC, means the collector current into resistance, collector resistance. Okay, whenever IC will increase, the voltage drop across RC will increase. This term is increasing and VCC is fixed, hence VCE will decrease. So we can observe here the VC is in the negative direction, means it is amplified but it is 180 degree out of phase than the input voltage applied at the base. Now during negative half cycle of input signal, VB decreases and hence IB decreases. So which means amount of electron emitted from the emitter will reduce, so that the IC current will reduce. So whenever IC current is reduced, which causes reduction in VC, so VC will reduce and hence VC increases in respect with the VC. Now so this can be understood by the output characteristic of transistor. In this graph, VC is on the x-axis, IC is taken at the y-axis, and this is saturation point, this is cutoff point, and when input signal is absent, the position of Q is at the center because we have biased this transistor in the active region. So Q point is at the center of the load line. So in this graph, we can observe that when Q point is at center of this line, so we can think the IB current is at this level and VC is at this point, okay, and IC is here. During positive half cycle of input signal, IB current increases. So IB current increases, which leads to increase in IC current. So Q point will shift upward and hence VCE will reduce from this point to this. Now during negative half cycle of the input signal, IB current decreases, hence IC current decreases. So whenever the IC current decreases, the Q point shifts downward and VCE increases. So in this direction, VCE is increasing. Now before going to simulate this amplifier, we have to design our own amplifier. So here I am not explaining any designing of this circuit, only I am showing here the values of all the resistance and capacitance used in this circuit. For designing of this circuit, I will explain in another lecture. So here we will use R1 and R2 at the 68 kilo ohm and R2 is 2.2 kilo ohm respectively. RC is 4.7 kilo ohm, RE is 220 ohm, and we will use RL as 47 kilo ohm. C1, C2 and CE, all three capacitors of the value of 2.2 microfarad. So whenever we will simulate this circuit, so we will use these values of resistance and capacitance. Okay, so let's do it in PSPICE. Now here I have opened the PSPICE schematic. So this is the editor and we will use the components from take component icon. So get new part, click here. So we need a transistor. So press here Q. So we will use Q 2 and 2222. Place this component here. Okay, now I need resistor R. Okay, place. So this is R1, this is R2, this will be RC, and here RE, and one resistor is for load resistance. Okay, enough. Now capacitor C. So this is C1, C2 and CE. Now we need one voltage DC voltage source. So VDC, place here. Okay. Now we need an input source. So input source will be a V sin, means voltage source of sinusoidal waveform. So V sin we will place here. Okay. And one ground terminal G earth. Okay, I got it. Now connect here. Okay, now we have taken all the components required. Okay, let me zoom to fit the page so that we can see all the components clearly. Now time to make the connections. So connect this point to capacitor and make all the connections. Just remember that while connecting all the components, please do careful so that all the connections should be proper. Otherwise, circuit won't work. Okay, so we have as good as done. Now it is completed. Okay, now after completing the connections, we have to give the values of the variables here. We will give the values to the components. Now this is VCC. So I will write here VCC. Now the value of VCC I am taking here 24 volt. Okay, you can take any other value. Then this is RL resistor. So the value of this RL resistor will be 47K, 47 kilo ohm. Now this is RC resistor, and the value of this RC resistor will be 4.7K. Okay, finish. This is 2.2 microfarad. So type U for micro, mu, and F for farad. Okay. Now this is RE resistor. The value of RE is 220 ohm, and the value of CE is 2.2 microfarad. Okay. Now this is again 2.2 microfarad. Here R1 resistor, it should be 68 kilo ohm, and this is 2.2 kilo ohm. Okay, so we have finished all the values. Now zoom to fit page. Okay, looking good. So now it's time to set some parameter of the V sin source. So we will click it and we will put the value of V of 0 volt, V amplitude. So I am taking it as a 10 millivolt and frequency is 10 kilohertz. Okay, so we have to type here. Okay, so I have entered all the values for V sine source. Now it is time to set up analysis. Now we are going to check the transient analysis. So check it now, transient. So print step from 0 millisecond to we will go for 1 millisecond. So just type here 0 millisecond to 1 millisecond. Okay, finish, close it. Now we have to apply a test point. So we are going to check the output voltage versus input voltage. So take the test volt, click here, and another is click here, because this is load resistor and this is input source. So V output and the V input. Okay, now it's time to simulate the circuit. So click on the simulate. Okay, so I will click it and we will observe the output of our signal. So in this graph, green line shows the voltage across RL register, means output voltage, and a red line shows the input voltage. So look at the height of this red line is very small as compared to green line. But after zooming it, we will observe here input signal is positive. Okay, this red line is positive. At that time, we are getting a negative response, means negative amplified voltage of the input signal. So we can conclude here that our amplifier is giving the output 180 degree out of phase, means phase reversal. So it was all about the transistor as amplifier. Thanks for watching. Bye for now.